Bismillah Rahman Rahim. Let's get started. So, in this lecture, we will talk about another example from image processing, and we will discuss how different concepts are mathematically modeled in image processing. So, in this lecture, we will consider some simple examples, although some of you might not be from image processing group, but these are simple examples, so I hope you will understand. Okay, so models for image transformation. So transformation means moving objects from one place to another in image. Rotate objects, so rotating objects in image. And scaling means that making them smaller or bigger. Manipulate and how object looks, so this is stretching. So these are the different transformations: moving objects, rotating objects, scaling, and stretching. And we will discuss how these different concepts are mathematically modeled. And Euclidean transformation. So Euclidean transformation are the most commonly used transformation. And Euclidean transformation is either translation, rotation, or reflection. And in these transformations, the angles and lengths remain constant. Okay. Now, let first start with translation. So let's say we have this image, and in this image we have this object. Okay. Now this image is represented by different pixels. So these black areas are represented by these pixels with zero values, and this object is represented with these pixel values. And what transformations mean? Transformation mean that, let's say, we move this object from this center to the side. So internally what will happen, uh, internally these pixel will be moved from this center to uh, this side. Okay, so this is translation. Or we can move it in we can move it to the bottom. So what this moment will mean? This means that again these pixels will move from the center to the bottom, and uh, pixels wise these will move from the center to this bottom. And we can also move this object to this right uh, bottom corner here. So in this case, these center pixels will come to these positions. Now we are interested how this moment can be mathematically represented. Okay, so uh, uh, this x prime and y prime are the new positions, and x and y are the original positions of the pixels. Okay, now for example, let's say if this is the original matrix, so this pixel is let's say 3 3, and it has been moved to 1 1, we can say like this. Okay, uh, originally its position was 3 3. On x-axis it is 3, and on y-axis it is 3, and now it is moved to 1 1. On x-axis its position is 1, and on y-axis its position is 1. Okay, so the new position is equal to the uh, previous position plus transformation along x-axis. And similarly, the new position along y-axis is equal to the previous position along y-axis plus ty means the transformation or the translation along y-axis. Okay. Now, let's say we represent these pixels. So in this case, the new position is this one. Okay, so this is equal to x. X is originally 3 plus tx. So here, plus, it is given plus, but it can be plus or minus. So x, and here it has moved, it is moved upward. So it is x minus tx, and it has been moved upward 2 points. So the original is 3 minus, uh, it has been moved 2 points upward. Okay, so minus 2, 3 minus 2 is equal to 1. So the new position is 1. Similarly, we can compute the values for y, where the new value is y is equal to 1, and the previous value is 3 plus ty. So again, it can be plus or minus. So y, uh, okay, I think previously I had given example of for y, because when I referred to this one, so it was moving upward and it was y direction. So this was a bit uh, wrong example. Again, x prime is equal to x plus t, so x is this direction. Okay, so from this point it has come to this position. Okay, like initially the x-axis was 3, but the new position, in the new position the x-axis is 1. This is the x-axis. And for y, so the first position for y is this one, and this is 3, and the new position for y is 1. Okay, so this is the actual moment. Okay, sorry for my incorrect explanation. Okay, so this t-axis is representing transformation along x-axis, and ty is representing the transformation along y-axis, and we can use this equation for this transformation. Okay, and in matrix form we can represent this equation and this equation through these matrices. Let's say this matrix represent the new position, this matrix represent the y position, and this is called the transformation matrix. Okay, so x prime is equal to this multiplied by this, and y prime is equal to this multiplied by this. Okay, and now this point, so this is just for the like for the modeling. So this is not important. We are actually interested in this x prime y prime, because in two-dimensional space we have only two x's, but for representing this equation we can use this matrix representation. Okay, now rotation, so it's a bit complicated, but I try to explain this. Let's say we have these two coordinates, x-axis and y-axis, and we have this pixel or point xy. Okay, and this is represented, this xy can also be represented by this angle with this vector. Okay, and we have already learned in our school mathematics that this can also be represented by this decomposition of this vector. So x is equal to r x phi, and y is equal to r sine phi. So this is the decomposition of this vector. And now we want that we move this point, we rotate this point from this position to this, uh, and this is the new position, x prime and y prime. Okay, and this is moved with the angle theta. So this angle theta is this one. So the moment is this much. Okay, and now if we decompose this vector into its subcomponents, so it is equal to x prime is equal to r cos pi plus theta, and y prime is equal to r sine pi plus theta. Okay, now uh, so x is equal to r cos pi, y is equal to r sine pi. This is the decomposition of this r and the vector for this point. And if we consider the point x prime y prime where the vector is r, so if we decompose it into its component, so for this vector the complete angle is this one, the combination of theta plus phi. So x prime is equal to r cos pi plus theta, y prime is equal to r sine pi plus theta. Now, if we use trigonometric identities, so these are the different trigonometric identities. We have already learned this in our class 9th or class 10th mathematics. So these are the different trigonometric identities, and according to these trigonometric identities, x prime, this one, is equal to r cos pi cos theta minus r sin pi sin theta, and y prime is equal to r cos pi sin theta plus r sin theta cos pi. Now, this is actually we have to look at this combination r cos pi plus theta. Okay, so cos pi plus theta, cos phi plus theta is this one. Okay, and this portion is replaced with this component. Okay, cos pi plus theta is replaced with this component, and uh, sine pi plus theta, sine pi plus theta is here, sine pi plus theta is here. So these two are equivalent. So in this portion, this one is replaced with this, and we get these equation by these replacements. Okay, now substitute x prime is equal to x cos theta minus y sine theta. Now again, uh, r cos phi plus cos theta. So cos theta is same, but r cos phi is equal to x. So if we take this identity, x is equal to r cos phi. Okay, so instead of this r cos phi, we have written x. Okay, and cos theta is at the same place, minus sin pi. Sin pi is same, but instead of r sin pi, we have written this y. And same is the case with the other equation, x sin pi. Okay, sin pi is same, but for r cos pi, we have written this x, and same is the case with y cos pi, where cos it is the same location, but for r sin pi, we have written this y, like here. Okay. Okay. Now in matrix form, we can represent these values with these matrices. This is the new location of pixel. This is the original location, and this matrix is the we can call this as rotation matrix. So if we take this rotation matrix and multiply this with the original matrix, so we can get the new matrix are values for the new location of the pixel. Okay, so x prime y prime is equal to r x comma y. R is this rotation matrix and this is this one. Okay, and if we expand it, so x prime is equal to like this multiplied by this one, or this multiplied by this one. So we can get these equations. Okay, or you can call it as mathematical model for rotation. Okay, now scaling is the concept of resizing an image. So let's say we have this object and we have expanded it. So how this is represented mathematically, we have this matrix which represent the new values of the scaled object. This is the scale matrix, and this is the value of the original pixels, and these are the new values. This is the scale matrix, this is the original values, and we can compute it as like the new scaled value is equal to cx multiplied by x. Cx multiplied, cx is actually the value of the x-axis in the scale matrix multiplied by this one, and y prime is equal to this multiplied by this. So from these multiplication we get these values. Okay, rescaling and interpolation. So this is the I think now these are the image processing concepts, but the objective of this lecture was like how we can mathematically represent the concept of translation and rotation. Okay, okay, so I hope it's clear now. Now, from this point onward, these are image processing concepts, and most of you might not be interested in these. So it was just to give you an impression how these different phenomena are represented through mathematical models. Okay, thank you.